Hello, friends. Welcome to the ATC Double Cut. We are going to take a careful look at water requirements of golf course turf, especially looking at some warm season areas. I have a very special guest joining me today. It is Dr. Matteo Serena, the Senior Manager of Irrigation Research and Services for the USGA Green Section. Welcome to the show, Matteo.
Thank you, Micah. It's a pleasure to be here and talking to you. I'm a big fan of your podcast, your content. So,
Well, thank you very much. I forget exactly when we first became acquainted. I certainly remember when you were a graduate student at UC. You got your PhD, and you got the PhD at New Mexico. Can you help me out with
yes,
how that went?
I originally am from Italy, so I got my undergraduate and my bachelor at the University of Padova in Italy. It's in northern Italy near Venice, and then I went on to New Mexico State with Dr. Bernd Leinauer, and that's where I got my PhD, primarily working with subsurface drip irrigation, new technologies like moisture sensing, and then being in the transition zone and having access to non-potable water. We did a lot of work with both warm season, cool season, um, and then after that, I joined Dr. Jean Baird at UC Riverside for a little bit over a year, and after that, I was picked up by the USGA in the new role as a manager of irrigation research and services.
That's right. Thank you for correcting me and setting that timeline correct. So you've had some really interesting and practical research. I think the drip irrigation stuff it seems very promising in terms of the amount of water that it can save and just efficiency of application of water. Could you summarize that?
Yeah, we've done several research tests on at our facility. So all of those obviously are controlled environment, with not traffic, not golfers. So just with that alone, we were able to document significant water savings, and I can summarize that at minimum at 30 to 35% are very achievable, just because you are eliminating overspray, you're eliminating this fugitive water that doesn't really reach the turf, and then you're delivering it right into the root zone. So there's minimal losses by evaporation and just the water trying to making it from the turf canopy down to the soil. Um, After that, a golf course in Santa Fe picked up the idea and started testing it on these island tees. And that's where we started seeing some significant savings, just because you're concentrating the water onto these island tees, and you don't have that incredible amount of overspraying. Um, and then from there, with the help of Brian Whitlark, just trying to slowly spread the word, and trying to get subsurface drip a little bit more popular. But there's always the question on aerification and what do I do. Obviously, the drip are installed at a specific depth, so you have to avoid aerifying below that depth, to prevent any damage.
What
Other,
what depth what depth is a typical drip irrigation installed at under turfgrass?
Typically, we put them at about 5 to 6 inches. So on an island tee, 6 inches depth. You're never gonna verify those. And we also have some anecdotal information that with the use of subsurface drip, there's less soil compaction. We have a study actually set up at Cal Poly Pomona to investigate that specific aspect. And then the golf courses, they're implementing and using that. They're recognizing that there is less disease when you're using, when you're irrigating from the ground, not having the turf canopy constantly wet. You have less incidence of dollar spot. At Last Campana, there's also told us they're seeing less POA germinating, and the big maintenance and implementation of that is just the reduce of vegetation growth around the tees. They are receiving excessive amount of water.
Yeah, it seems to have a lot of potential, but there must be some practical limitations. You brought up the difficulty in irrigation. Sorry, in the difficulty in cultivation or
Yeah.
aerification because you have them at a fixed depth in the soil. Although if it's at 6 inches or 15 centimeters, you may not need to go that deep with with the usual type of cultivation. How about just like the products themselves? Are they expensive or do they get clogged up? I know I have this idea in my mind, maybe that I heard 30 years ago that drip irrigation could get clogged up or something. And then all of a sudden you've really got a problem because how are you going to get water out? So
Yeah.
are there those technical issues that it still needs to get, the technology needs to get improved a little bit? Or is it there?
I would say compared to 30 years ago, technology has made significant advances in terms of like clogging and root intrusion prevention. The emitters technology, it just it's so far ahead these days that these are not the perforated pipes or some of the original material that was introduced when like some of the earlier study in Arizona, for example. Filtration, it's a key component. So every time that we install or we recommend a subsurface drip installation, it always have to have a filtration system, either at the valve or a larger filtration if not present. And the other aspect you mentioned is cost, which it's pretty substantial. I would say material itself, not probably about, I would say about the same as a sprinkler system, but then you have the whole process of installation, which is complicated. And currently, um, the, we we still see the need of almost like a double system, and that's probably what is going to be the most limiting factor. Is that I don't think at this time you can get away completely without a sprinkler system or without enough precipitation during the year, evenly spaced, to, for example, watering chemicals, fertilizer, and other component.
Oh, yeah. I've got another question. If you're using water with a high salt content, I'm accustomed to managing that with adding extra water, what's called a leaching fraction, to cause some of those salts to move below the root zone. If you have only a drip irrigation, how does that work when you're adding water that has high salinity? Are you able to apply the leaching fraction, or do we have to think about that in a different way?
So during our research at New Mexico State, where we were using uh, saline groundwater, which it was at a probably about 2,500 of total dissolved solids. So we definitely see an accumulation in salinity on in the root zone. These over the course of like long-term study, so we're talking about 7 to 9 years. Cool season grasses did not survive. So the salinity buildup was enough. The cool season were not able to survive the period where salt was accumulating, and then seashore paspalum and bermudagrass were doing just fine. But we also saw that on those type of soil, or if you have a sand-based profile, you're building up salt during the season, and when you don't have precipitation, and then when you have rain, you are leaching the salt out. But yes, it could be a concern if you're in a very dry environment where precipitation is limited. And keep in mind in New Mexico, we had on average 8 to so it will be like what 16 to 20 centimeters of precipitation. So it was very dry.
Yes. Okay. Thank you. Yes. And we have a very international audience for this show. I think maybe 45%, but less than 50%, I think, are in the United States. So the greatest number of people who watch this or listen to it will be in the United States, but still a majority, more than 50%, will be from outside the United States. So I am very comfortable for us to flip between or translate between metric and United States customary units if we are able to do that. So we can say inches and centimeters, and that's perfectly fine.
Yeah, growing up in Europe, I never understood the imperial system, but it's something that you get used to over time.
Yes, and I, growing up in the United States, never understood the metric system, and then it's also something that you get used to over time. And in my case, I find it much easier to work with, and so the default for me now is to think of it in metric. And sometimes I forget. Like I was looking at irrigation, and a lot of stuff in the United States is in acre feet.
Right.
In the American Southeast, it's in acre feet, and I've been translating that into millimeters because I like to think because here's why I think millimeters is so easy. If we think of evapotranspiration, we can express it in millimeters. We think, well, the evapotranspiration rate today was 6 millimeters. That's about a quarter of an inch. So that's a nice evapotranspiration rate, 6 millimeters or 4 millimeters. But we can also just keep adding that together. And then over the course of the year, we can say, well, the irrigation requirement at this location, we estimate to be 1,437 millimeters or 1.437 meters. But you can't do the same thing with acre feet because you can't say that it's such it's too small of a number when you use acre feet for evapotranspiration. Which is why that then goes to inches, and then people do it a fraction of an inch. So instead of using a whole number like 4 millimeters for today's evapotranspiration, we'll use a number like 0.16 inches, which is it's more difficult to say. And then you have to go to a different unit for the annual total and start talking about it in acre feet. I just find the simplicity of doing things in metric is more convenient for me. But all of the numbers mean the same thing, and so we just try to translate between them as best as we can.
Yep. Yeah. I mean, you put it very nicely, and it's so much easier to relate into millimeters, especially like when you have ET, and then if you have a square meter or a hectare, to convert that into a cubic meter of water versus like So
Yeah, I agree. And you can also take like soil moisture content if you have a volumetric water content in the soil, and then you assume that your depth, I like to assume the depth is 4 inches or 10 centimeters, which means 1 square meter has 100 liters of volume, which makes it really easy to say that your 15% soil moisture content is equal to 15 liters, which is equal to 15 millimeters spread across on the surface. And so all of these just instantly are connected in a way that I haven't figured out how to do with inches, acre feet, and so on.
When you figure out, let me know, because I haven't either.
All right. Well, cool. And then I think the reason why I had it stuck in my head that you had been getting your PhD at Riverside is because I was so interested in some of the articles that you published from around the time that you were there, I think. And then some of the stuff that you were doing with Zoysia and bermudagrass and buffalo grass and the pictures you were sharing. I want to talk about one article real quick that I think you were the lead author on, and that was the water reduction that you could get on bermudagrass, I believe, when you applied growth regulator and wetting agent. And that was like a 25 or 30% reduction in water use with the same turfgrass quality. Do I remember that correctly?
Yes. So that study actually originated with my colleague and my study partner at the time, which is Marcos Schiavone, Dr. Marcos Schiavone. He's now at University of Florida. And so the way that he started doing this PhD was looking at soil surfactants and plant growth regulators in combination with subsurface drip and sprinkler, and see what was helping with drought. At the time, there was some very limited information, most of it coming out from cool season grasses. And so it was some novel research to do. And so you had like separate chemicals doing, one was working on the plant, like the plant growth regulators. There's information about having the potential to reduce ET. And the other one was the soil surfactant, which doesn't do anything for the plant, but it works in the soil. So the idea then came on combining both product and see what were the benefits in reducing water use. And that's where followed up studies that eventually were published showed the benefit of the combination of the two on bermudagrass under drought conditions, and we reduce ET. So we were able, during the summertime, we were able to maintain acceptable quality with approximately 25% less water.
That's a huge number. That's one that I've often talked about as like low hanging fruit for fairways in Thailand, for example. Let's talk about Thailand, which is 100% warm season turf, and a lot of fairways get sand capped because the soil tends to be not so good for during the rainy season. So to keep the courses playable during the rainy season, it's useful to have a 10 or 15 centimeter sand cap on the fairways, sometimes more. And so, and then it rains for like 6 months, and then it doesn't rain for 6 months. So you've got a 6-month period when you really need to irrigate. And the problem is sometimes the water storage isn't quite done properly, or it doesn't rain as much as people might expect. And suddenly they come to the end of the dry season, or maybe midway through the dry season, and they're like, uh-oh, looks like we're running out of water. And now you've got fairways that are grown in a sand root zone, which clearly that's going to need some water. And I find people don't use soil surfactants and don't use growth regulators as much as they could. And I'm like, if you want to instantly reduce your water requirement and keep the turf quality the same, you want to reduce the water requirement by 25%, This is something that I would try to implement, which is adding a soil surfactant, which is going to allow the water to be distributed more evenly within the soil. Add a plant growth regulator, which is going to reduce the grass's use of the water, and you end up with better quality. So I just love that paper.
Thank you. And I've actually, with my current position at the USGA, I've been trying um, for the last year or so to find a golf course with a GPS sprayer that would like to test this idea. All of this was done, and even with the tremendous work that Dr. Baird is doing at UC Riverside, testing multiple chemicals every year. They're always at a test site. Plots are very small, 5x5. They're not golfers there. There's not traffic. So I really want to take these into a golf course and see um, what's the return on investment. Is it working, or have we missed the target?
Yeah, that's always good. Things so we can't just take something that was done at a research area and was published and it wasn't really repeated. It was repeated enough in the experimental setting to get published, but it's not like that's been repeated in Dubai and it's been repeated in South Africa and it's been repeated in China and it's been repeated to show that it also works on cool season grass and it also works on paspalum. And that's why it's good to continue learning and continue testing. And I'm so glad to hear that you want to do that kind of thing in a place where it's getting traffic. Speaking of traffic, and also kind of continuing on things that you could apply. What if you add in a pigment or a color? So now you can tolerate, let's say you could tolerate the discoloration of the turf that would come with reducing water not by 25%, but by 40%. So let's say you reduce the water use even more, but you're using a surfactant, you're using a plant growth regulator, and you add in a dye or a colorant. Now that's going to it might make it look even better than it does if you add water at 100%. But why I mentioned traffic is, of course, if you have the grass that's growing so slowly, and then you put traffic across it, I'm not sure that might last good for a month, but I'm not sure that you might end up killing the grass. But those are the kind of things that would be really interesting to research, I think.
Yeah, and a lot of this work have also been done by Dr. Jean Baird group at UC Riverside in the last, I would say, 5 to 7 years, where he's looked at combining all of these products, including pigments, including mineral oils, and I've often joked with with my colleague, Dr. Cole Thompson here at UCR, because when you look at some of those reports, you have a fungicide, a phosphite, a plant growth regulator, a soil surfactant, and I forgot what was the other product that he put in the mix. And yes, you might be able to achieve like 50 or 45 or 50% of water reduction, but at what economical cost? When we did the math on these, we're talking about $450 to $500 per acre per application. That's quite expensive versus applying a generic surfactant in a PGR, which you could be roughly at about like $50 to $70 per acre. So yes, you can achieve like tremendous potential with multiple chemical application, but there is always the cost, the return on investment on the cost of water. One thing that I wanted to add is regarding the traffic in the stress tolerance, is that we've never quantified it, but what we've seen is that even if you're experiencing a decrease in quality, we noticed that the turf that was treated with either surfactant, PGR, or other product recover faster when you give the water back. So maybe you're losing quality, but compared to a control, it takes a couple of extra weeks to get back to a healthy turf canopy versus a turf grass that has received like some products.
That's very good to know. Thank you very much. Okay. Now let's talk about species and overseeding and some of the stuff that I saw that you shared. I think I'm going to bring up, because this is the ATC double cut. We'll talk about a blog post. So I'm going to bring up a post. Let's see. I've got a post on the screen now. Of course, for those of you who are listening, we'll describe what we're saying. For those of you watching, you'll be able to see it. This is a post that has the title Zoysia Water Use and Fact Checking. And it's a post I wrote in 2021. And it is a post that I'll put a direct link to in the show notes so everybody can check it out. This is something that I read an article in the Global Golf Post, and it just flat out stated, zoysiagrass, quote, requires less water than bermudagrass, end quote. And I was kind of complaining that there might not be so much fact checking in golf industry magazines. And I suggested that egregious error would have been corrected had the article been fact checked. And then I shared some pictures that you had shared. And I believe this was from the time that you were at UCR. And
well, this one was at New Mexico State, but the results were basically the same at UCR. So
okay,
the study,
so the picture that I shared was from New Mexico.
Yes.
Okay. And so this is a study that I believe it was summarized in that 2023 article, the article last year in the Green Section Record that has the title Measuring and Comparing the Water Requirements of Warm Season Grasses. Is that the same project?
Yes.
Okay. I shouldn't talk too much about it because you did this and you wrote the article about it and you're quite familiar with it. So why don't I just stop here and let you describe what that experiment was all about?
Okay, so the experiment was funded in collaboration with USGA and the NTEP, which is the National Turfgrass Evaluation Program. And it's set to establish 5 areas to test different crop coefficient on warm season grasses and at 5 different locations, in 5 other areas which were on a rainout shelter. Same grasses, but instead of having 3 crop coefficients, they were set inside a rainout shelter, and then over the summer, irrigation was shut down, and then they used digital image analysis to calculate when the percentage of color was dropping below a certain percentage, and then based on that, they were giving back water to recover cover. So you have 2 studies at multiple locations in which shows basically how much water it takes to maintain turf canopy green, and the other study that tells you if you irrigate on a deficit of irrigation, what's the percentage of quality or green that you'll have. So it's almost like you have a chronic stress and an acute stress. With the acute stress will be the rainout shelter, and the chronic is the crop coefficient. And the study included bermudagrass, zoysiagrass, and buffalo grass. And
Right.
when
And the buffalo grass here, because in Australia, buffalo grass is Stenotaphyrum secundatum. So the buffalo grass that we're talking about here is the American prairie grass, which might have a new name now, but it used to be Buchloe dactyloides, right? What is the name, the scientific name for buffalo grass these days?
I'm old school, so I'm still stuck with Buchloe dactyloides, but I make a note that I need to check on that. I know that tall fescue I've changed. I was not aware of
Yeah.
of buffalo grass.
Yeah, so I remember one time an Australian friend of mine in Thailand, I was going to the U.S. and he said, "Can you bring me some buffalo grass seed?" So I bought buffalo grass seed in the U.S. The Buchloe dactyloides, and I brought some of it and I gave to him, and he planted it and it germinated, and he said, "I've never seen buffalo grass like this." So I think you got me the wrong grass. and it was at that point that I realized that the common name for buffalo grass in Australia is Stenotaphyrum. That buffalo grass is Stenotaphyrum, or what Americans call St. Augustine grass. So,
Yeah, I did not know that.
yeah, well, it's interesting.
Yeah.
Okay, so yeah, this is a really cool study, and I loved it. Whenever anybody would share pictures of this, and you shared some of the best pictures of it, and the grasses, when you would apply the acute stress, which is like the drought, and you'd let it start wilting, and then you'd add water to regreen it, or when you're adding the chronic stress, which is 30% of ET or 40% of ET or 60% of ET or something, you start to see these profound differences in the grasses, and it just seems so clear what the results were.
Yeah. So in the Southwest, beside, I would say probably one cultivar of zoysia grass, the Bermuda grasses in general outperform in terms of like green color and turfgrass quality the zoysia grass and definitely the buffalo grass. There is a running joke with the buffalo grass that, you know, if you want a drought tolerant grass and you plant buffalo grass, you'll get brown color twice a year. So the winter time and the summertime. um, but you know, for example, in Nebraska, where probably buffalo grass is more suited to that environment, it's doing quite differently than in the Southwest. So that's kind of the summary of it.
And so I reviewed the article, which I'll put a direct link to that 2023 USGA Green Section record article that summarizes these results. So basically, the first part of the study, I think it said that at the Mississippi location, zoysia required more than twice as much the amount of irrigation as did Bermuda grass. And you'd calculated, averaged across multiple locations. You'd calculated for, I think this is what you'd call the acute, which is where it went in a rain out shelter, or you had a drought and you waited for the grass to reach unacceptable quality. Then you added plot by plot irrigation with known amounts of water to restore back to acceptable quality. And this was in inches, but Tiff Tough was 0.02 inches per day on average across all sites. Tahoma 31, 0.02 inches per day. Tifway, 0.03 inches per day. And the very best zoysia was 0.04. The worst zoysia was 0.07. So we're looking at from 2 to 3 times more water was required in the case where we don't have enough water, where we run out of water, and we have to maintain acceptable turf grass quality with the absolute minimum amount of water. I'm looking at those results saying it seems pretty clear that zoysia required from 2 to 3 times as much water as Bermuda grass. And I think I understand it correctly because it was such a simple study and the results were presented so clearly. So you're not going to argue with me about that, are you?
No, I'm not. I'm not arguing. And what we'd also see is that the when you are shutting the water, the Bermuda grass has a stronger mechanism for surviving than zoysia grass. I'm not arguing also because those Bermuda grass tested are probably currently the top of the cream on the market. We're talking a Tiftaf, Tahoma 31, which is shown to be very drought tolerant, even more than the common or older cultivars like Santa Ana or a 419 Tifway. And the zoysia grass tested, some of them were experimental, some of them were new, but I don't think that at the time we had anything released yet that claimed drought tolerance. For example, now I know the Dr. Susanna Miller-Lewis at NC State has released a new zoysia grass that has improved drought characteristics. So it will be interesting to test newer plant material. When we compare the breeding effort, zoysia grass is lagging a little bit behind compared to Bermuda grass, and they're doing a lot of work to catch up with that, in my opinion. And that's what kind of makes me more like optimistic and hopeful that zoysia grass will have a better chance in the future.
Yeah, it might. I think there's a lot of diversity within zoysia grass. And I think the ones that are currently on the market are perhaps selected for leaf texture and things like that. Not so much for some of the disease resistance, perhaps not so much for some of the drought tolerance. And so some of the stuff like Zeon, when they did the multi-site study in the American Southeast looking at drought, Zeon, which is the commonly used commercial variety, tested worse than all the experimentals in terms of survivability under drought and turf quality under low water use. So it does seem that there is quite a bit of potential. I want to show a picture about what I tend to see in reality. I'll bring that up on the screen. This is a picture in August. Let's see.
Yeah, I remember you posted that on what's now X.
Yeah, what's now X, which not so many people are on X anymore, so they may not see it. This is a golf course in Japan, and it is common during a drought at this location. It hadn't rained for about a month, and it was evapotranspiration rates of 5 or 6 millimeters per day during that period. And this photo was taken at the end of August. And this is Zoysia japonica rough that has gone completely dormant, and it's unirrigated. And the Bermuda grass that's a weed in that location is still green and growing. And that is something that you can see whenever there's a drought in Japan and areas go without irrigation. You see that Bermuda grass remains green and growing, and zoysia grass goes completely dormant. I was in Japan last week again, and I visited a golf course in the same prefecture. And in their parking lot, they have they have some grassed areas in between different sections of the parking lot. And some of that zoysia, even though it's rained some since then, the zoysia is still completely dormant, and one wonders what it's going to be like next spring, if that's still going to be zoysia or if it will die. So it's certainly something that I see in reality. Like, Bermuda grass keeps growing and stays greener longer, and clearly it needs less water, because the picture that we're looking at shows green Bermuda grass and it shows dormant zoysia. So it's obvious that in order for that zoysia to be green, it needs more water, and the Bermuda grass does not need the water, as evidenced by looking at the picture. So that's why I have this idea in my mind that there's research in the U.S. that shows that Bermuda grass uses half as much, that you can have acceptable turf grass quality with half as much water for Bermuda grass as with zoysia. And then my own eyes and experience of growing grass tells me that Bermuda grass uses less water. But then I read in the media, like in that blog post, where there's a lack of fact checking, and there's this article that says that zoysia grass uses less water than Bermuda grass. I see from people that are selling zoysia grass, they often claim that zoysia grass uses less water than Bermuda grass. And then I am intrigued to see that you're doing some research or monitoring some research in the American South, looking at grass as a replacement for Bermuda grass, with the idea that you may not need to overseed.
Yes, I lost you for a second, but I think I know what you were asking.
Yes,
Um,
I hopefully I wasn't too lost.
yes, so I'm following a couple projects in the we call it the Bermuda Triangle, which is the area from Phoenix, Coachella Valley, and Las Vegas, that we're testing zoysia grass as an option to replace overseeded Bermuda grass. And the idea, it's originated because even golf courses, they're wanting to replace the current Bermuda grass with a new one, like a Tiftaf or Tahoma 31. They require and uses less water, in particular in the summer. They're still going to need to overseed, just because the traffic and the playing characteristics of those courses during the winter time will not be acceptable for the majority of the golfers in the area. They want to play on a nice surface, which is a growing grass, and typically it's overseeded with ryegrass. And so the process of overseeding, it's getting more expensive. It requires water, fertilizer, seeds, a lot of labor on beating down the Bermuda grass. We know how intense overseeding is. It also requires a golf course to be closed for roughly a month, and that is a loss of revenue. So golf courses are trying, or we are experimenting or suggesting the use of zoysia grass, because study have shown it doesn't take overseeding very well. You can overseed it, but it does not recover as well as Bermuda grass. So the recommendation is to not overseed zoysia grass. And the playing surface and the math that it creates, it's more resistant. So there's studies out there. Tennessee have investigated the divot resistance and the amount of energy that it takes to make a divot on zoysia grass versus Bermuda grass. It also is more tolerant to traffic. So the idea is that if we find a zoysia grass, which it also has the characteristic to retain the color and green up much better and quicker than Bermuda grass when it goes into dormancy, It doesn't need to be overseeded, so you can get by for 2 or 3 months with some pigment, or if the golf course accept the yellow color, it still offers a nicer playing surface compared to non-overseeded Bermuda grass. So that's kind of what the idea behind these trials are.
Thank you. Thank you for explaining. I looked at an article that Brian Whitlark published in the Green Section Record recently about getting ahead of water restrictions and being proactive and considering things. And I got a number there. He said that overseeding is going to be roughly 25 or 30% more water. Is that a number that sounds reasonable for you, that if you stop overseeding, you could reduce water use on an annual basis by 25, 30%? Is that reasonable?
Well, the number, yes. So if we look at research and if we've talked to superintendent, and if we look at data from courses that have gone from overseeding to non-overseeding, on average, the good number that goes around is 25% less water when you not overseed Bermuda grass. And this number takes into consideration the amount of water that you need to establish the grass and the amount of water that you need to bring back Bermuda grass. And it also take into consideration watering Bermuda grass during the winter time when it's dormant. It still needs, research that was done several years ago from the University of Arizona shows that if you can get by with not irrigating at all. But courses, they don't generally tend to do that, just to keep the dust down. You want to keep the crown of the Bermuda grass to a moisture level where it's able to like come back in the spring versus having to come back only from the rhizome, which will probably take a little bit longer. So if you don't irrigate Bermuda grass at all, you're probably looking at 4 extra weeks of recovery time. So with those number in mind, 25% less water, it's reasonable.
Okay. So I'm combining that number with that multi-site study that showed that if you use TIF-Tuff or TIFWay, or TIFWay is pretty good, and Tahoma 31 is quite good, and TIF-Tuff is quite good. So if you use those and you really try to use as little water as possible, compared to the zoysias that were in the study, you could use 50% less water if you use Bermuda versus zoysia. So that's the part that sticks in my head. I understand about the potential to get away from overseeding, but if you change from Bermuda grass to zoysia grass, with the idea, if the purpose here is to save water, how does that save water if you've just now you don't have to overseed. So now we don't have to overseed, so we've saved 30% water. But we've just installed a grass that requires twice as much water. So the math there in terms of water use does not add up to me. And then I'm just like, man, what are people thinking? And I know that you're involved with this, so you can explain to me what people are thinking and why am I an outlier on this? And people are actually using zoysia when it's known that it needs so much more water.
So the concept that the zoysia grass needs like double the water is when you are imposing a drought condition. So the idea behind is from what we're seeing currently on the installation in Phoenix and Coachella Valley is that you can maintain zoysia grass with the same amount of water that you can maintain Bermuda grass. I understand that if you are on a drought and you have to reduce the irrigation because you're forced to cut watering, then you might be better off with the Bermuda grass. But currently, there is not restrictions on those places. So when we compare the standard irrigation utilized in those two areas, we can comfortably maintain zoysia grass.
Can
The
I can
other,
I can I just interject to make sure I understand this correctly? I guess so. So I'm thinking of, if we're trying to minimize water use, then we are going to put as little water as possible. And in that case, if we put as little water as possible, that's where we see the benefit of Bermuda grass using less water than zoysia and providing a better golfing surface. But if we're not trying to use as little water as possible, we don't have water restrictions, and we're just putting out more water than the grass actually needs to produce a surface, then in that case, we have Bermuda and zoysia the same. Am I understanding that correctly? So we're talking about minimizing water use, but in reality, we're more talking about like not really trying to use an absolute minimum of water.
I think that it just depends on, like, from course to course, and what reality that they are in. Um, the bigger pictures here, I think, is trying to move away from overseeding, or maybe only overseed half of the course, or maybe we get to a point where we don't have to overseed the entire course. And currently, in this climatic region, with the number of rounds that they're getting, they cannot get away with Bermuda grass. So the the purpose of putting, and this is what I've heard from some golf course manager, is that they've switched to either Tahoma or Tif-Tuf, is they can use less water during the summertime. So that is when you're in a drought, summertime, in this region, sometimes you're close to half an inch of ET per day. So that's a very substantial use of water. So they're implementing Bermuda grass to get to use less water during the summertime, but then they still need to overseed during the fall. So starting, like September, October, up until like March or April, they are growing ryegrass. The idea, or I guess the concept of using Bermuda zoysia grass instead, is that you probably gonna need to use a little bit more water in the summertime than the Tif-Tuf and the Tahoma, but then you don't go through the period of overseeding. So the golf course can be open during those transition months, September, October, and generally sometimes even November. And the other advantage of the zoysia grass is less mowing and less fertilizing requirements, which is also becoming another issue, not unrelated to water, but
Yes, and potentially increased fungicide requirements.
Yes, there is also a good difference between zoysia grass cultivars, and so that one is also have to be looked at. But there is a potential for some more fungicide applications, although I don't know if we have a full pictures on that.
Well, I think because Japan has thousands of golf courses, and most of them are zoysia tees, zoysia fairways, and zoysia roughs. And I'm somewhat familiar with how that grass is managed. And so the problem is, when you don't overseed, you don't have much tolerance for large patch, because large patch is a particularly hideous looking disease, and when your grass is not growing, those patches just stay there. Bermuda grass can get large patch, but it certainly recovers faster from it, and it seems to be less susceptible, showing less visible symptoms than zoysia. So it's common in Japan to make 3 annual wall-to-wall applications for large patch prevention. And of course, there's also prevention of spring dead spot, which is, maybe that's even more of a problem on Bermuda grass, but that can also be a problem on zoysia. But if you're not overseeding, I think you really have to prevent the large patch. So, there's those kind of things that come to my mind. And then I'm like, zoysia is better than Bermuda in terms of tolerating more winter traffic and still making a golfing surface, but the divots still don't recover. Of course, you don't have as many divots as you do with Bermuda because of the resistance to taking divots, but it still gets divots. So if we go to Japan, where the fairways are all zoysia for the most part, and where it's not overseeded, and they just would typically paint the fairways or color the fairways 3 or 4 or 5 times during the winter, you can get to the springtime where low areas around the greens are roped off as ground under repair because the divots haven't recovered. And that's not at every golf course, but you see those kind of things. And you can see areas that are sloped where the ball, there's some uphill holes where the golfers complain in the winter on zoysia because they hit it up and the ball rolls back down to the bottom and they just can't get their drive up over that hill. And it's still a dormant turf grass. It's better than Bermuda grass, but it still has the problems of it's not growing. And so I'm just so skeptical about it. And I look at the American Southwest, that Bermuda Triangle of the Coachella Valley to Phoenix to Las Vegas, and I think, well, the water situation, the water availability there is probably not going to be getting better in the future. It seems likely that water used for amenity turf grass would be stable or decreasing. And I'm like, why would we introduce, as an industry, a grass that, if we really have restrictions, it's not going to do as well as Bermuda grass? But I know if I was an operator, if I was an owner of a golf course, I sure would love to have revenue 12 months out of the year. As a business decision, I could see not having the disruption of overseeding could be very attractive. So I think it's exciting to see how this goes, because if the breeders can come up with some zoysias that can tolerate periods of drought a little bit better and allow golf course superintendents to turn down the irrigation without risk of the grass going completely dormant and not coming back for 2 months, that could be quite promising.
Yeah. You mentioned, and I respect, that you're like so much experience with all of these golf courses in zoysiagrass, in Asia, that's where it's from. But like, one thing that we haven't mentioned is that in Coachella Valley last year, we hardly had any frost. So I was out there at the end of December, and we were still picking up clipping from zoysia grass. So the climate, it's getting a little different. Maybe 10 years ago, there were frost events, and they're already talking about that this year is going to be another warm and wet winter. So if we're not looking at longer period of dormancy, it could be a good solution. But you're right. Sometimes we're here trying different things, and to find one that is successful, you'll probably go through other 9 that are not successful.
Yeah, I agree. I think my frustration with it is when people put nonsense in magazines or on podcasts and just state that Zoysia uses less water than Bermuda. And and then I see some of the research, which is fine, and some of it is going to fail, but you will learn so much and maybe find a nice solution. But then I get frustrated by the whole idea that, like, people write to me and they just, like, they're assuming that Zoysia uses less water because they've heard it. And I'm like, that, I don't know where you're getting this kind of information. I know there's Dr. Baird's got some Bermuda grasses that retain nice color through the winter. And you talked about one of the benefits of Zoysia is requiring less mowing. And, so usually we think that Bermuda grass grows more than Zoysia, which makes us think that the Bermuda grass that stays green in the winter, it might, if it's Bermuda grass, it might have better divot recovery. So it's hard to balance in my mind the idea that Zoysia grass could be requiring less mowing, but then it's also a benefit that it's green and growing in December. It's sort of like, to me, it seems like it's picking and choosing things that make it look good. And that's just because of my bias. I'm biased here against Zoysia in this location. So I call that picking and choosing. In reality, we'll have to see how it works out, because I don't like playing on a course that's just been overseeded. I don't like playing on a course that's just coming through the spring transition. And Zoysia just has that consistency through the year that may be quite nice. So yeah, cool.
Yeah, another aspect that we were struggling. So the study, actually, the way it started, I got Breather and Salt Farm to send me plant material to the Coachella Valley, because none one over there it's growing Zoysia grass. So if you need it, you have to get it from outer states. The closest Salt Farm that has one Zoysia grass cultivar, it's in Scottsdale. And so by the time that I got all the ducks in the row, we planted in July, because you expect it's a warm season and it's hot temperature. So we put it out in the hot time of the year, and then it just sat there, and it just was not growing. And then this year, we decided to, against all odds, against all of the suggestion, they were saying, you got to put it out and you got to sprig it in the summertime. We sprigged it in April, and you'd be surprised at the results that 120 days after sprigging, some of those Zoysia grass cultivar, they've reached 100% of cover, and I could say that some of them you could comfortably play off. Maybe not have intense traffic, but if you give them another month or two of growth, that's a pretty substantial success. And that's another thing that oftentimes we hear that goes against Zoysia grass is this low rate of establishment. And so even finding, the right planting time, maybe some amendment, playing with the irrigation and the nitrogen, as well as the sprigging rate. It's something that we're going to have to look if golf courses are deciding to start looking more seriously at, like, these Zoysia grass.
Wow, I'm learning so much. This is awesome. Thank you for sharing all of this information with me. Before we finish, this isn't your role is Senior Manager of Irrigation Research and Services. I think you do a lot more than what I've been hounding you about today. So could you describe a little bit about your role and some of the other big projects you're working on? I've heard about, like, 2040 or something, some kind of reduction in water and stuff.
Yeah.
So
So
could you explain that?
yeah, so the main role that I was hired at the USGA came through the new CEO Mike Wan in it, we call it a big bold leadership initiative, and it was named 15-30-45, which stands that in the next 15 years we'll invest $30 million to help golf courses reduce water use by 45%. And the way that we set that one, that moving forward, is pretty much by taking some of the most experimental research or some of the unutilized technologies and trying to bring it into golf courses and see what works, what doesn't, what do we need to improve. So some of the basic, for example, is put some numbers into like irrigation system maintenance and updates. We have courses, they're very diligent, and they keep the sprinkler head levels and with the proper angle and the proper adjustments, and versus there are some that are not doing such a great job. So, and unfortunately, we don't really have a good numbers on the benefits of doing that, just in terms of like distribution uniformity and also moisture uniformity. Brian Whitlark is a big supporter of the moisture uniformity, as well as like some of the newer technology they're getting into the market, which are able to determine, or you can even do it with a simple moisture meter and map your moisture distribution, things like that. We see a lot of benefits in improving. The vast majority of the golf courses, they still irrigate based on feel. Yes, they might have a weather station, they might take a look at the data, but not so much. Not even talking about soil moisture sensors. We probably can count in a hand the people that are using soil moisture sensor to irrigate their golf courses. So I think there is a lot of improvement that we can make as an industry. I think overall we're doing already a good job, but that doesn't mean that we have to stop and continue to do a much better job.
Yeah, thank you for explaining that. Yeah, it's tough sometimes for me. I'm in the turf industry, and sometimes I'll talk with people and they're kind of anti golf because it's so obvious, because golf uses a bit of land that you see when you're flying in airplanes. So somebody flies into Phoenix, they see a lot of green golf courses, and other areas are not so green. If you fly into Palm Springs, you see a lot of green golf courses, and other areas are not so green. And people are like, man, what's going on with all the water that you guys are using? So it's politically, it's a tough one. And I'm not quite sure myself how to answer it. If you say, why should there be golf in Dubai? It's sort of like, well, if there's going to be people in Dubai, if there's going to be people in Las Vegas, then we want people to have a nice life. And for people to have a nice life, we need to have recreation, and we need to have the benefits that turfgrass can provide, such as oxygen and cooling and other things. So, yeah, I guess it's a bit of a constant effort to do a big, bold initiative like this and communicate. And then at the same time, I think the industry does pretty good at using water efficiently, because for playability reasons, nobody wants to have too much water out there. But at the same time, there are technologies available that would allow people to use water more efficiently. And when you use more efficiently, you'd end up using less water to get the same or better results. And being a golf course superintendent is a big job. Being a golf course maintenance team is a big job. And I think some of that stuff, people just, they don't have the time and the energy to allocate to that, right? Because
Yep.
it's like if you're going to go do individual head control and then adjust, everything, and like really the best way to irrigate should be to hand water, but that takes a lot of people. Or, drip irrigation. You're like, okay, well, we need to install a drip irrigation, or we need to invest to change all our grass to Tiff-Tuff or something. Some of that stuff is just, there's opportunities, but some of the stuff is challenging for people to implement right now. So I think you have a lot of opportunity to do so many good things that will have a huge and lasting impact on the world of golf.
Well, thank you. That's very good to hear, and hopeful. Sometimes I don't feel that way, just because like it seems like a big number to bring in on the savings, but when we look at trends, the drought conditions, just today I was speaking with someone in the Long Island area, and they were saying that it's been 2 months since they had any sign of rain, and the aquifers are getting lower, and so they're looking at solutions. They're looking at bermudagrass. Last year I talked to someone in Canada. They were asking questions about bermudagrass, and I would have had never expected that, but water, it's always, I feel like, is always becoming a recurring problem, and I'm happy that as this USGA, as an organization, we're putting some effort into it. I remember when last year we had the meetings, and we're looking at other organizations, and everyone kind of talks, and you say like, well, we should do something about it. And then here we have at least the USGA, which is investing money in research and promoting water conservation. So I think like that, at least we're on the forefront of that.
Are they going to invest in your travel to the International Turfgrass Research Conference in Karuizawa, Japan next July?
I hope so.
I hope so, because I'm leading a zoysiagrass symposium there, and we're going to talk about things like zoysiagrass breeding and drought tolerance and use of zoysia, stuff like that. So, and also on the field trips, you'll get to see lots of zoysia, and maybe some bermudagrass as a weed.
I look forward to that. Over there in Asia, what are the zoysiagrass utilized? So is there is there a breeding program? Are they making hybrid, or is just like what is locally available?
Basically, the ones that tend to be used are what I'd call a land race, which is a variety that's been selected for working well locally, and then they're vegetatively propagated. And the sod farms themselves in Japan or in Vietnam or in Thailand might choose a particularly good variety that they then vegetatively, but it's a land race. It's one that they've selected. And it tends to be done by the people who are selling it. And I know there is research about breeding in Japan. I haven't seen a lot of new cultivars actually come to market. And in China, I know there's a bit of breeding, but I don't know that those varieties ever get on the market outside of China. And then, so that's what the domestic production of zoysia is. So in Japan, for example, when you buy a grass, you would say you refer to the geographic location where it came from. So this is a grass that's like from Kumamoto, and so it's from a sod farm in Kumamoto. That's what they're selling, and you might not want to use that around Tokyo, but it might work good around Kumamoto. And the Totori is a famous prefecture that the sod farms there have good grass. And so they'll have like Zoysia matrella, they'll have Zoysia japonica, they'll have greens grade Zoysia matrella, And there's a golf club, Naruo Golf Club, which has developed their own in partnership with one of the sod producers, where they found a really nice variety on their first green, and they've developed that into something called Naruo Turf, which I've seen at test plots, test greens, and at Naruo Golf Club, they've resodded all their greens with that grass. I was just there last week, actually. It was quite nice. So there is a breeding program, but it's sort of like more based on selection, I think. That's what I observe. Now, you also have the American producers who've taken Zoysia that's come from Asia, and then they evaluate it or breed it in the United States and see, oh, here's how it performs in Florida, here's how it performs in North Carolina, here's how it performs in Texas, and they choose the varieties that they want to make commercial within the United States. And formerly there was, from California, there was El Toro and Victoria, which I saw a Victoria nursery, which I don't know that that's even commercially available in the U.S. now. I saw a big Victoria nursery in Kagoshima, Japan, July, just a few months ago. So there is some of the grass that comes back to Asia. And so you see Zeon is used a lot now, not so much in Japan, but certainly in Southeast Asia, because people have the idea that imported grass is better than local grass. Now, I disagree, and I have anecdote to show it of Zeon is particularly poor with drought, and it's particularly poor with salinity compared to the local land races. So if you put them side by side, the Zeon looks worse. But you can't market the local ones. And I know in the Philippines, which Zoysia matrella, the common name is Manila grass, because that type of fine-bladed Zoysia is found all over the Philippines. And Manila Golf Club had Seashore Paspalum. They had Zoysia greens. And in 2007, 2008, they did a renovation, changed it to Paspalum. Paspalum had some issues with the shade, and of course Paspalum on a green doesn't quite have blazing fast speed, but the main problem was with the shade, and so they decided to change the greens at Manila Golf Club to Zoysia, but they couldn't use a local variety because you've got the committee and they think of like the local varieties as inferior, so they used Diamond, because Diamond at the time was something that was commercially available. It comes from the U.S. and it has a name. Now you put Diamond on the greens, it throws seed heads at green height. The local varieties throw fewer seed heads. So then the local varieties vegetatively contaminate the green. Now somebody like me notices this. The golf course superintendent notices it. The golfer may not notice it so much, but you've got the Diamond that has all this white in it because it's got seed heads at green height, and the local varieties look better. But the superintendent who made that conversion was like, he can't even present because nobody's really researching the local varieties. So like Diamond would have a sales sheet. Zeon has a sales sheet. Primo Zoysia has a sales sheet. Stadium Zoysia has a sales sheet. And when you go to an owner or an architect or whatever, they look at that and they're like, ooh, certified grass. I want that. But actually the characteristics of some of the land races are quite good. And Dr. Kenworthy from University of Florida was over in Hong Kong, Vietnam, and Thailand in May of last year. We looked at some of the Zoysias that are growing wild on golf courses and that are planted, some of the land races that are planted. And then we looked at that Zeon versus local variety comparison too. And he saw it. He knows that there's a lot of genetic diversity in Zoysia. There's a lot of good ones here. But as far as what gets sold, if you're a golf course architect, they always are going to want to buy the one that they've heard of that's used in Texas. But it doesn't mean it's going to work so well in Bangkok.
Yeah.
So that's the situation.
Got it. Yeah, no, I was just curious, but like hearing you talking, it's one of the things that I than I recommend. And some courses that have asked me, I always tell them, just put a little variety trials in place. It doesn't need to be replicated, but just do a couple of square of, if you're planning to do Bermuda grass, try at least 5 or 6 different cultivars. And if you're doing Zoysia grass, just kind of do the same thing, because they're going to perform differently um, in different environment. And one of the things that we've learned recently is the heavy seed head production of teeth tuff in Northern California, which makes Tahoma 31 be more favorable. And then sometimes, courses still pick Santa Ana just because, it's just still such a great grass that, when you are putting a side-by-side comparison on a property, do you want to pick the best for your property? So, just have a small trial for a few seasons and see how they perform.
Yeah, I agree. If you look at that study that you looked at the different warm season grasses and water use, the Zoysia performed much better at 30%, 40% ET at the New Mexico location than it did anywhere else. And maybe it's New Mexico, or maybe it's just the soil type that it was in. And the soil type in New Mexico, or the way it was managed in New Mexico. But in that case, you could look at it and say, now I can get all the benefits of Zoysia without the drawbacks in that location. But you may not get that result in Florida or at Riverside. And I think there's a lot to be said for the way people manage and all of the site specific things. And that goes, for anything. Bentgrass. I see a lot of bentgrass trials, and it's interesting how you'll see some bentgrasses perform really well in one place, and you put it somewhere else, and it could be completely different. So,
yeah,
test yourself. All right. Well, we've gone a little bit over an hour, Matteo, but I have certainly enjoyed this discussion.
Same.
Learned a lot. We've been talking about we need to have this chat sometime. Finally, we do it. I think maybe we can do it again sometime too.
Yeah.
You can update me all the time about how things are going, because if I'm wrong about this kind of stuff and my strongly held opinions, I want to correct it, and I want people to help me to understand things clearly, so that I can really understand what's going on and not talk nonsense.
Yeah. But and like sometimes I'm even ask myself and some of our colleagues if we're wrong. I know that you had a conversation with John Petrovsky recently on the USGA podcast, and he mentioned that he had a lot of material that was not published that he wanted to share with me, but
Oh yeah, I don't. Maybe I did a rant about Zoysia. I don't know, but that was a lovely podcast. I hope to have a chance to talk with him again sometime. He asked some really interesting questions.
Yeah, he prepared for it for sure. So we like John. He's a great host.
Yeah, excellent. All right. Well, maybe I'll be at the GCSA conference, so maybe I'll see you there. I'll go to the BTME, so I'll be in Harrogate if you're going to pop over there.
We will have I think we're in the process of planning a water tour over one of those interactive facility tour related to water. Hasn't fully had the plan yet, but yeah, just look for that, and I'll probably be there in San Diego.
Oh, nice. Yeah, that could be really good. All right. Well, thank you so much.
Thank you.
I will look forward to our next discussions about water, and if I have any questions, or I guess if anybody has questions about water and technologies and stuff like that, they know where to get in touch with you. Just Google you at the USGA.
Yep, my contacts is there.
Awesome. All right. Thanks a lot, Matteo.
Thank you, Mike.
All right. Bye-bye. I'll sign off now. For ATC from Trong, Thailand, I'm Micah Woods. Bye-bye.